Okay, today we'll go with the next mapping of Hibernate, that is association mapping. So association mapping is used to establish relationship between two persistence classes. Persistent classes means what? Entities. Yeah. For example, student and address, department and employee means see, you'll have to establish sometimes relationship between student and address. Sometimes you'll have to establish relationship between department and employee. Means student has an address, department has an employee. So in that cases we'll be going for what? Association mapping. So association mapping is generally done when there has a relationship between classes. The relationship between two classes is defined in terms of two things: cardinality and direction. So these are two new terminologies what you are going to understand in Hibernate. These two terminologies will be understood with more examples only. Okay, they have a lot of meaning, but I'm introducing these two new terminologies now: cardinality and direction. Cardinality means what actually? Number of occurrences. Means how many times it is occurring. That's the actual meaning of English meaning of cardinality, number of occurrences. So the definition for that in Hibernate is, it defines the number of persistent classes participating in the relationships. Yeah. Then direction defines the direction of the relationship between two classes. So this is the definition. Meaning I'll be explaining you with examples only. Fine. Then next, the most important point now, in Hibernate there are following types of association mapping based on cardinality and direction. Means based on this cardinality and direction, there are four types of association mapping in Hibernate. Which are they? See the first one now, many to one. Okay, one to many, one to one and many to many. So these are the four types of association mapping. Again in each one, means in many to one, you got something called as unidirectional and bidirectional. Again in one to many you got unidirectional and bidirectional mapping. Again in one to one you got unidirectional and bidirectional mapping. And in many to many also, last one you are having unidirectional and bidirectional mapping. So these many mappings we have to cover now in association mapping. Clear? So fine. So we'll be going to the first one today, many to one unidirectional I'll take. So I'll be going with an example for many to one unidirectional mapping. So that's the heading what you're going to see now. Okay. Association mapping, many to one unidirectional. So to understand that, let me give you an example. All these terms you will understand only with example now. So you more focus on example and output, automatically you start understanding this terminologies now. Yes, the example for this what I'll take now is very simple. Many students are staying in one hostel now. So that is an example for what? Many to one. Many students are staying in one hostel or PG accommodation or something. So let us see now. I'll design the table first. Okay. Yeah, first I'll create the address table. It will have an address ID. It will have city. And it will have zip code. Zip code means pin code. So this is going to be your address table. Fine. Now I told you many students are going to stay in what? One address. So for students we'll have one more table now. So this also will have SID, it will have SNAME column. Okay. So and it will have one more column called as AID. So let us study these two tables clearly here. So many students are going to stay in what? One address. So let's come back to this now, address table. So here I will be making address as the parent table. Clear? And student will be made as the child table. This is the parent table and this is the child table. Yeah, in this table, parent table, which is an address table, this will be the primary key. Address ID will be the primary key. And in student table, this will be the primary key. And can you guess what is the idea? It is foreign key. So this will become the foreign key now. And this foreign key is linked with what? This AID foreign key is going to be linked with the address ID primary key in address table. So fine, this is how the design of table is done now. So if you want to still clearly understand the design of this table, I'll fill some test data. You'll get the idea very clearly. Test data means here, there's an address now. 1, a city is Bangalore. I'm taking one city Bangalore and zip code is 560010, means there is a hostel in Bangalore now, and that's the zip code or pin code. Fine. Let us take 3 students who are staying in this address now. Like student number 1, his name is Ravi and he's staying in the address Bangalore. So it will be 1. One more student, Ravi. Then I'll take Kumar. He's also staying where? In the same address. One more student, Amog. He's also staying where? In the same address. This is the test data I'm filling now. Let's take one more address. Like supposing there's one more hostel in Mumbai. Yeah? Some pin code I'll take 600023, something like this. Okay, that's the zip code or pin code. Fine. Now, assuming that there are 2 more students who are staying at this hostel now, a hostel in Mumbai now. So let's see this now, test data. 4, Vinay. Where is he staying? In Mumbai. One more student, Girish. So where is he staying now? In Mumbai address. So this is the test data. So you're getting a rough idea now. What is the concept I'm talking now? Many students are staying in what? One address. Yeah. So this is how there are 2 tables and they are 2 related now. Fine. Now these are the 2 tables in your, assuming that these are the 2 tables in your project now. So if you're having these 2 tables in a project now, we'll have one scenario now. I'll bring one scenario to you now. See here, the scenario is very simple here. You're going to have an UI, enter student ID. You'll ask the student ID to be entered. You'll ask the student ID to be entered and the user will submit the value. So your duty is now, he'll make the request now. He'll make the request to the application and your application should interact with the database and give all the values. This is the scenario now. This is your application. So the ID will be entered now. Supposingly, if I enter the ID as 2, so and submit it. Now see, in your application what you are supposed to do? You have to connect to the database, fetch all the values from the database and display the student and his address in the view now. Yes or no? So what will be that he will be displaying? Your ID is what? 2. Your name is, all the details will display now. Your name is Ravi. Sorry, second one is Kumar, no? Then next, the next detail. Your city is Bangalore. Then your zip code is 560010. So these many values you have to display now. Are you following now? So when the user enters the value, you have to connect to database, fetch all the details and display it back to the user. So this is what is our requirement now. Clear? So yes, you have understood the requirement now. So and you are going to pull the data from where now? 2 tables. Yes or no? You are going to pull the data from 2 tables. Which 2 tables? Student and address. Because right now the data is in 2 tables. Given a student ID, you have to retrieve the record from 2 tables. One is a student and address, so you have to retrieve the data from both the tables and put it into a TO or an entity. Yes or no? So this is your actual scenario now. First you will store it into entity, then you will display it in the UI. So let's now start understanding how you design your entity. Clear? So the entity, this is the request and this will be the response. Done? So let's see how you design your entities now. Yes, for every table you will have one entity that is known now. So this is how you will write your class now. Entity means your Java class. So you'll have one student class entity here now. So this will be student, correct? Then you'll have address. So these are the two entities you're going to have now. So in student, what are your properties? Int, SID you will have, fine. And next you'll have what? String, name you'll have. That's also okay. Fine. Now let's come to address. Here what you'll have? Int, address ID you'll have. The next one you'll have is string, city. The last one what you'll have is string, zip code. So entities you are designed. So one entity student is representing one table called as student. Another entity address is representing one more table called as address. So that you have designed. But the thing is now you have to relate these two entities. You have to relate. See, the scenario is now student has an address. Student has an address. So whenever there has a relationship, how do you relate the two classes? Very simple. You will make address as an instance variable of what? Student. Very simple. So this is how you will go on defining your entities. So your address is a variable of what? Address. So this is how it will be done now. So this is how you have to generate the entities. So once you design your entity like this, now it's very simple. You can fill this data into this entity in a very simple manner. Now how will you fill? First you will prepare the address, and after the address is ready, then you will prepare the student, and then you will give the reference of the address object to the student. It will be, reference will be given now. So this is how they will be related. Done? So fine. This is what is association mapping. Means you are associating student with the address. Clear? This is what is called as association mapping. Association mapping is always done when there is has a relationship. Clear? Fine. So that is how it will be done. So once these entities are ready, next you have to do the mapping now, because we are talking about what? Object relational mapping. Yes? So we have to do the mapping. Here clearly understand. See, in object relational mapping there are two different worlds. What will happen is one is the relational world. The other one is the object oriented world. So carefully notice here. Here in the object oriented, in the relational world, how do you relate to entities, to different things? In the relational world, we relate both the tables using a ID. ID means primary key and foreign key. But in the object oriented world, we relate two things as what? These are two objects. So if you want to relate these two objects, it can be done only with a reference. That is why what we are doing is we are having a reference of the address object in the student entity. Clear? So here you will have address as a reference, and that is how they will be related. So fine. So once these entities are designed, last one will be mapping now. So let's see how you do the mapping now. See, this property will be mapped with one column. See how they will be mapped. So this will be mapped with the SID. This column. Name will be mapped with what? Name column. This property again will be mapped with address ID column. This is how the mapping will be done. Done? So in your mapping file, Hibernate student.html.xml file, you will do the mapping, and this is how they will be mapped. And here how you do the mapping? See, this address ID will be mapped with what? This column. Then city will be mapped with what? This column. Zip code will be mapped with this column. So this is how they will be mapped. So one tag you will use and you will do the mapping. And finally here what you have to understand is student has complete information about address, notice, but address does not have any information about what? Student. Means if you have the address object, you will never get the information about what? Student. But if you have the student object, you will definitely get the information about address. So that's what I am trying to say. Student knows, student has got complete information about address, but address does not have any information about student. So that is why we say this cardinality, this direction becomes what? Unidirection. This is unidirection now, because it is one way. From the student I can access the address, but from the address I cannot access the student. That's why it is called as unidirection. One side it is. Clear? And again here if you see, this is direction. Now cardinality, if it comes, see this is M. and this is 1. Many students are staying in one address. So that is why this becomes M and that becomes 1. So that's what we are understanding. See the point now. Association mapping means relating two classes. That is what you mean by association mapping. Fine, relating two classes or entities. Then next, many to one is what? Cardinality. Many students are staying in one address. Lastly, unidirectional means what? This way means from student I can get the information about address, but from address I cannot get the information about student. That's why it is called as unidirectional. Direction is like this. From student we can get the information about address. So this is the whole concept now. So the table is there and you are having your two entities. So after these things are done, next is what now? Do the mapping and do your CRUD operation. Means you can insert a record or you can read your record or do whatever you want now. And the beauty of this is, if you write so much of Java code and if you associate these two entities and all that, see while inserting, generally if you want to insert a record like this, how many queries you have to write? Imagine. For every record you want to insert, you have to write one query, no? So that will be eliminated. Similarly, when you are going to read the record, you have to do joins, complicated joins and all. Now you are just talking about two tables. So that time what happens? You write complicated joins and read the data from both the tables. Now all that will be eliminated. So I'll just write the client code and show you how you are going to save the record as well as how you are going to read the record. Are you clear with this now? So only one thing will be pending here. What? Seeing about the mapping file. Yeah. So first I'll write the client code, then we'll go to seeing the output. So understand all the concept here. Are you understood now why I designed my entities like that? This was our requirement because given a student ID, I want to get his address. So that is why I related what? Student with address. So this was the scenario. So fine. So let us see the client code. I'll write the client code for two things now. One is for inserting and another one is for reading. Yeah? See the client code. Class demo PSVM. See, first I have to, if I at all I want to insert Bangalore, no, I'll take the same example here. If at all I want to insert the record for 3 students staying in one address, see what I'll do. First I'll create the object of address. Address add1 is equal to new address. Means an address object will be created. Next, what will I do? Address1 dot set. Address1 dot set city, and I store the value of Bangalore. Then address1 dot set zip code 560010. Then next, after the address I'll create the student object. Student1 is equal to new student. See this, student1 dot set yes name. I'll give the property name as yes name. Okay, so set yes name, what will it be now? Ravi. Then student1 dot set address you have to do. You have to associate now. You have to link or relate the address with this student. That's why I'm saying set address, and I'll add this address now. Add 1. So now they are associated or related. Otherwise what happened? Address was a separate object, student was a separate object. Now we associated. Then next, one more student I will say. Student stu2 is equal to new student. Then stu2 dot set yes name. The second name is Kumar. stu dot set, again you have to associate that address with what? This student also. So what will I do? Address 1. Correct? Then again 2 students ready now. Student stu3 is equal to new student. stu3 dot set yes name of Amog. stu2 dot set address is of address 1. Fine. So all the 3 students are staying in an address. Now if I want to save, you know how to save now? Means you have to get the, from the session factory, get the session. Session factory means you can get the session factory from the util class. Session factory SF is equal to Hibernate util dot get session factory. From the session factory get your session. Session is equal to SF dot open session. Then transaction TX is equal to session dot get transaction. TX dot begin. Then you are having the session now. You have to save. What will I do now? See here. Session dot save. Student 1. Session dot save. Student 2. Session dot save. Student 3. That's it now. All the 3 students will be saved into the database. Means one will be inserted into the parent table. Which one? Bangalore record will be inserted into the address table, and Ravi Kumar Amog and Ravi Kumar and Amog will be inserted into the student table automatically. So such a simple process now. So Hibernate becomes really beneficial when you start working with what? Multiple tables like this. So the ORM feature of Hibernate is very powerful when you are working with multiple tables like this. When you are having multiple tables, what you will do? You will design the tables, that is okay. But to map them, what will you start doing now? You start using association mapping. You will have the entities and you start associating like this. And then you can work now. It will become so simple now. Clear? So if you are not using Hibernate, assuming that we are using what? JDBC. Now how many queries you would have you written now? First you have tried the query to insert into address table. Then you have tried the query to insert into student table. So 1 query for address, 3 queries for student. So 4 queries you have tried. So such is the complication if you use JDBC. But if you are using Hibernate, what happens? All those complicated queries you will not write. And benefit is what? In JDBC you have to see the drawback in JDBC. You have to learn native SQL queries. But in Hibernate we are not learning any native SQL queries. So all the native SQL queries will be generated by the Hibernate. That is the benefit now. So this is how it will work now. Are you clear with this? Fine. So this is how you can save the what? Records into the table now. Now I'll show you how to read the record. Means that direction I have to explain to you now. What is many to one direction? Unidirectional I have to explain to you now. So that direction I'll explain to you now. Are you clear with this? Shall I clear this now? So this is for what? Saving the record. Whatever code I have written is for saving. Next I'll be talking about for reading the record. Let's see this now. I'll clear this now. Yes, so if you want to read now, what will you do? This is for reading now. For reading a record. As it is, you will get the session. Directly I'll start from the session now. See this now. So I want the student and his address. So here I'll write student can access address. I'm commenting. This is the comment I have written. Student can address what? Access address. Means see this. Student STU typecast. Student session dot load. Yes sir. Which one? Student dot class comma new integer of 2 I will give. Means I am going to read the record of Kumar, correct now? So I'll give 2. You can use primitive also here because it will. We are using Java above 1.5 now. So wrap class, it will be converted to object. So 2 I can give. So the return type will be what? Student object. Yes, from the student I can access what now? See here. Int ID is equal to stu dot get student ID. I can call the getter methods now. Yes. Then string NME is equal to what? stu dot get yes name. I can get his name. That is fine. You can get his ID and name. But the most important thing is I can get his address. How will I get the address? See this. String, or I'll take int. One more ID will have now. Okay, I'll take it as AID only. This is student ID. Okay. Int address ID is equal to stu dot what? Get address. Get address will give you what? Address object. Dot get AID. That's it. Then next int, you want city, It is string. So string city is equal to stu dot get address dot get city. Fine. Then next string zip code zc is equal to stu dot get address of dot get zip code. So you can get all the values now. So simple. So you mean student can access what? Address. But are you clear with what is this now? So using the student I can get the address. But if I load the address, I can never get what? Student. Because student has no, address has no information about student. Address is having no information about the student, but student is having complete information about the address. So let me show you that also here. See, I'll write it here. The code would be address add is equal to session dot load of address dot class comma first address. 1 I am writing, new integer of 1. Address is loaded now, but from address what I can get? ID I can get, city I can get, zip code I can get. How will you get all the students? You cannot get any student information only. So that is why we call this as what? Unidirection. Understood? So that is why it is unidirection. So I mean say int address ID is equal to add dot get address ID. I can call the getter method now. See, these are the only properties here. For these properties we will be having what? Setter getter methods. So I can get his ID, I can get the city, I can get the ID, I can get the city. Add dot get city. Fine. I can get the zip code. Add dot get zip code. Fine. But you can never get the information about the student. This is only the concept. So it's a very simple concept. So concept you understood. Okay, means what is, how are the tables designed, how you are going to create the entities, what is the client code, everything you have understood now. Only one last thing what you have to see is now what? How do you do the mapping in the XML file, and the other one is with annotations. Both I will cover now. Yeah? So here you can write on extra point. What? I am not having space, but here you write address cannot access student because of unidirection. Yeah? Fine. I'll clear everything now. We'll go to our examples. Yeah, the 7th example I'll take. I'll show you how to do this mapping with what? XML first. So you have written down your tables. So here you see the entities now. First address you see, address.java, this is the entity, AID, city, zip code. The next entity what you have to see is student, SID, SName, address. Yeah, so this is how you are having the two entities, setter address and all is there, fine. Now, first let me open the address.hbm.xml file, mapping file I will open. Let us see the how the address entity is mapped with the table now. Address entity is mapped with what? Address table. Let us see that first. Very simple, you know how it is done. Nothing new here. The AID is going to map with AID column, city will be mapped with city column, zip code will be mapped with zip code. Here nothing to worry. Okay, so every property of your entity will be mapped with what? Every column. Then next, here what you have to understand next is in student. Okay, this is your entity. In student.hbm.xml file, see how the mapping is done. This you know, SID will be mapped with what? SID column, not a problem. SName property again will be mapped with SName column, no problem. But here see, we are using a tag called as many to one. So many to one tag is used generally for foreign keys. AID is a foreign key in student, no? AID is a foreign key in student. So that's why you are telling many to one. Name is equal to address. This is the property now. In student there is a property called as address. Class is of type what? com.cluster.address. There is one more attribute you have to use. Cascade is equal to all. Just use it. Next class I will be explaining what is cascade attribute and give the value as what? All. So that much you do. Column name is equal to AID. Means the address property you are mapping with what? AID column. And remember, many to one is used for foreign key. Clear? Many to one tag is used for foreign key. That's all mapping. If you do this much mapping, now you can start using the two entities with your table. Clear? So let's see this now. So all the mapping you understood. So now, see in the same example, in the last I kept tables.sql. So all the tables are queries there. So I'll just open it. So these are your tables, just now which I had drawn. These are the script. So what I'll do, I'll run this program on what? MySQL and show you now. So first, I'll go to MySQL. I'll use the test user. So we're in the test database now. So yes, let's run the queries one by one. See, always drop the first. I'll just run off the drop query. Understood? Always drop what? Child table first. Make it a habit. Drop the child table first. So if it is there, it will be dropped. So table is not there, so I am getting that error. But if the table is there, it will drop the table. Always drop your tables first. Next, which table you will drop? Address table. Fine. Yeah, that table also is not there, so I am getting that error. If the table address was there, it would have been dropped. So fine. So first I try to drop the child table, then I try to drop the parent table. Fine, that is okay. Now what will I do? I will create the table now. So first you have to create which table, but while dropping child first, parent next. While creating parent first, child next. So I will do it now. So I will create the first address table. I will copy and paste the query. Yeah. So okay, means one table got created. Which table got created now? Address. So next, I'll create the student table. Fine. So both the tables have got created. So see the select star from address. I'll show first. So there are address, double D, address. Okay. So there are no records. Then I'll say select star from student. So there are no records in both the tables, but the tables have got created. Fine. Now let us see how to insert the record now. So we have seen the two entities. We have seen what? The tables. Okay. Then mapping also you saw. Entities we saw, tables we saw, mapping we saw. So now only we have to talk about the client code. Configuration file is normal. Okay. Yes. But one more thing what you have to understand is in configuration file, see we are having two HBM files now. We are having what? Two mapping files. So in configuration file also you will have what? And that is one thing extra here. How many ever mapping files you are having, all of them you should mention here. You are having two now. One is address.hbm.xml, other one is what? Student.hbm.xml. So how many ever mapping files you are having, all the mapping files should be mentioned in the configuration file. That is one very important thing now. Fine. So all these things you saw now. Entity, tables, mapping files. Okay, then configuration files. Only last thing what we have to see is the client code. Let us see the client code now. See, this is your client code. Very simple. As I wrote, same thing I am showing you here. I got an address object created here. Clear? Then the next thing, student 1 is created. Ravi and see, first the address object. And it is what? Bangalore and 560010. So then next, the student I am creating. Student is equal to new student. Set S name. I'll set the name as Ravi and I'll set the address. Means I am associating what? That address with this student. Means we are relating the student and the address. Otherwise that's a separate object. This is a separate object. So you are giving the reference of the address object to student now. That is what you are actually doing. So fine, next you are creating the second student and giving a name here. Similarly what you are doing now? Associating the address with this student also, or relating the address with the second student. Same with third student Amog. So after creating it, we are associating or relating the address with this student also. So that's how you have created the entities. We are seeing how to save now. So then you know this is normal code now. What? Hibernate util.get session factory. I'll get the session, session factory. From the session factory I'll get the session, and from the session I'll get the transaction and I'll begin the transaction. Inside the transaction what I'm doing? I'm saving all the three students. Student 1, student 2, student 3. All three students will be saved now. Yes? This code you leave now and I will commit. I've commented that, leave it. So that's it. Very simple code now. We are seeing how to insert the records. So that's it. So we have to run the code now. So you can see there, Hibernate is only generating the queries for us and inserting the records into the two tables. Brilliant it is. See this? Clear? So let us go and see in the database now. First select star from address. Yes, one address is there. Then next student you want, 3 students. Brilliant now. So what are the benefits of Hibernate now? We are not learning native SQL queries. We are not writing complicated queries, means many queries now. If the same thing you want to do with JDBC, you have to write what? Minimum 4 queries. 1 for address, 3 for student. But now you are not writing any query only. You are just working with what? You are working with the database as an object. You are treating the database as only an object. So it is very easy. So whenever you want to work with the database, you are going to work with what? Only something like setter, getter, you work like that now. Earlier you are working with database how? By writing complicated queries. But now you are working with the database with setter getter method. This is Java world, means object oriented world. So this is how it is done. So fine, if you want to insert one more record, that also I'll show you now. We are having one more now, Mumbai. So let's see that now. How will you insert it? So I'll change here only. Some pin code I'll give. So fine, who are the 2 students staying there? Fine, only 2 students will save now. This I will comment. Done. And I will save 2 students. See there also what happens. Again, the queries got executed and the data has been saved into the 2 tables. Select star from student. You can see very clearly Vinay is staying where? 2 means Mumbai. This is the foreign key now. Similarly, Kirish is staying in 2 what? Mumbai. See, I show you the address if you want to. They are staying in Mumbai hostel. So this is the simplicity we get when you are working with Hibernate. Clear? All the queries are executed by Hibernate system itself. Fine. So now you understood how to save the record. So what we'll do now is we'll see how to retrieve the record. See here, very simple. I had already written the code for you. Session.load. Understood? I am loading what? Student. But with the student I can get what? His ID, his name, as well as his address also. See this. See, we are only calling getters, but it is only running the query and getting you the values from the table. Which table? Two tables. One from address table and the other is from student table. Brilliant, no? So we are not writing complicated join queries. All that we are not writing. So the data is in two tables. The data has been fetched from both the tables now. Clear? So then next. This is how, means from the student I can get the address. Noticing it is firing two queries. The Hibernate system is actually running two queries. One query to get from student, other query to get from address. Means whatever it is the case, but it is executing the query for us to retrieve the records from both the tables and give it to us. Done? So fine. So from student I can get address. But the reverse is not true. From address I can get what? Only address details, but not student details. Same variable name was there. I just changed the variable name. Clear? So I'll get the address now, but I can never get from address. I can never get the, means which student is staying in this address I'll never know, but I'll get only the details of address. It will run the query, you'll get the values, but you're only getting the details of address, but never the details of student. That is why I'm stressing on that point, is because now you have to understand what is unidirection. The relation means the direction is only from what? Student to address. The direction is always from student to address. That is why it is called as unidirection. Many to one. Direction is what? Many to one. That is why it's called association mapping. Many to one, unidirection. Association mapping means relating two entities. Understood? That's the actual meaning. Association mapping means relating to entities. Then many to one means cardinality. Many students are staying in one address. Occurrences, number of occurrences. Cardinality means number of occurrences. Then lastly, unidirection means it's the direction. From student I can access address. That's why it's called unidirection. Yeah. So quote this example. Only one thing what you have to understand here is, main thing is in student you are using this many to one tag. This is the most important tag now. So if you want to do many to one unidirection, you have to use this particular tag, and this tag is used generally on to map with foreign keys. That's the only concept here, main concept. Okay, that's it then. Okay, one second. We'll complete what? Same thing with annotation. So we have seen XML now. The same concept what we'll see now with annotations. See, this is annotation. The next example. Same, everything ditto to ditto same. There's no change. All the concepts remain same. Only the thing is we are not having the mapping file now. We will not have a external file. So that is the benefit of what? Annotation. Okay, if you use XML, one headache is what? Source code is in Java file, but mapping you will do it in another third party file. But if you use annotation, the mapping you will be doing it in the same source file. That is the benefit of annotations. That's all. So see this. First I'll open the address. This also, you know, last class I have covered annotations and at the rate of entity to mark that it is an entity class. It is mapped with which table now? I'll use annotation at the rate of table name is equal to address. Fine. This one, you know, ID, generated value, column, everything is same here. This one get city. So this is same. So you don't have to worry about what? Address. Only change you have to see is what? In student. So let us see now student. Here also everything you know. Only we have to bother about how this property is getting mapped. SID, you know, it is very simple. I'll show you. See this. SID mapping will be done like this. It is mapped on the primary key ID, generated value column, all these annotations are covered. So fine, then next, name you know now. Last thing is get address. So here you are using what? Yeah. So instead of column you are doing what? Join column. Till now you are using only column, but here you will use what? Join column annotation. Name is equal to AID. Means AID is a column in student, no? AID is actually a column where? Student table. This is a properties here. This entity is getting mapped with, remember, student table. Student entity is getting mapped with student table. So that's why this property address will be mapped with foreign key. Foreign key of address. We are having the foreign key of address in the student table now. So that's the foreign key, it is linked. So that is what you are writing here. That's it. Other thing, at the rate of many to one tag you are using, you have to use many to one. Cascade is equal to cascade type dot all. These two annotations if you use, it will work. Cascade type dot all is a enum. Cascade type is a enum. That's it. So use this. That's the only thing what you have to understand in annotation. So I have covered XML and annotation in unidirection. So if you want client code, same, there is no change. If you want, I can run it and show. See, I am running, the same values are there, the client code. So what I will do, first I will show you that in the database you can see that these are the records. When I run the same program now, what will happen? Again one more backdoor will be inserted, but understand this is getting inserted from the annotation program. Yes, we are running the annotation program now. See this. One more record got inserted, address and from student. But this is with annotations what you have done. The 8th example. Clear? So clearly understand, I have named, how beautifully named, see this. 7th program, leave it, association many to one unidirectional XML. That's the name I have given. For this one, association many to one unidirectional annotation. So it is very self-explanatory project name I have given, so that you can follow it easily and refer to it whenever you are having doubts also. So that's it now.